Hello students, welcome to Excellence Classes Way of Learning. Before starting the second exercise of this chapter, first we discuss about some operations on matrices and their properties. Okay, let's start the topic operations on matrices. Let's see the first operation, that is addition of matrices. Addition of matrices. In this operation, let's see the sum of two matrices. The sum of two matrices A and B. The sum of two matrices A and B of the same order, A and B of the same order is obtained by adding the corresponding elements. If we have two matrices A and B of the same order, then their sum, उनका सम फाइंड करने के लिए हमें उनके करस्पॉन्डिंग एलिमेंट्स को ऐड करना होगा. ओके, वी हैव टू ऐड द करस्पॉन्डिंग एलिमेंट्स ऑफ द गिवन मैट्रिसेस A and B. Okay, clear? The sum of two matrices A and B of the same order is obtained by adding the corresponding elements of these two matrices. For example, let A be a matrix equals to 2, 1, 4, 3, -1, 6, and B is equals to 1, 3, 5, -4, 1 and 7. Okay. So, A plus B, sum of these two matrices is equals to 2, 1, 4, 3, -1, 6 plus second matrix 1, 3, 5, -4, 1, 1, 7. Okay. So, to find the sum, we have to adding the corresponding elements. Okay. So, 2 plus 1, next is 1 plus 3, 4 plus 5. In second row, 3 minus 4, -1 plus 1, 6 plus 7. That is equals to, first element is 3, next is 4, 9, and in second row, that is -1, 0 and 13. This is A plus B, sum of A and B. Okay. Now see the properties of this operation. Properties of matrices. Properties of matrices addition. Okay. Let A, B, C be the matrices of the same order m into n. Okay. Clear? एडिशन ऑपरेशन है, सो मैट्रिसेस का ऑर्डर सेम होना चाहिए. ओके. सो हियर फर्स्ट प्रॉपर्टी इज द कॉम्यूटेशन लॉ. एडिशन ऑफ मैट्रिसेस satisfy the commutative property. Okay. The commutation law. According to this, A plus B is equals to B plus A. It's satisfying the commutative property. Okay. Next. So the commutation law says that A plus B is equals to B plus A. Next is the association law. Association law. According to this, if we have three matrices A, B and C, then A plus B plus C is equals to A plus bracket B plus C bracket close. Okay. पहले हम A प्लस बी को ऐड करके अगर उस सम में C ऐड करेंगे दैट इज इक्वल्स टू अगर हम B प्लस C को पहले ऐड कर देते हैं और आफ्टर दैट A को ऐड करें. दिस इज एसोसिएशन लॉ. इट satisfied द एसोसिएटिव प्रॉपर्टी. नेक्स्ट इज द existence of additive identity. Okay, the existence of additive identity. Let 0 be a null matrix. 0 that is order है इसका m into n. 0 be a null matrix of order m into n where m rows and n columns. So according to this property, A plus 0 matrix is equals to 0 matrix plus A is equals to A. Okay. Simple है. If let a number 2 plus 0 is equals to 0 plus 2 is equals to 2. Same for matrix. Okay. The existence of additive identity. Okay. Next is the existence of additive inverse. Previous property क्या थी आपकी? The existence of additive identity. This is the existence of additive inverse. Okay. For this, let A be a matrix that is equals to small a I j order m into n, and we have an other matrix minus a, other matrix minus a is equals to minus a I j order m into n, such that a plus in bracket minus a bracket close is equals to a minus a equals to 0 matrix of order m into n. Okay. In this way minus a is called the additive inverse of A. In other words, we can say that minus A is the negative of matrix A. Okay, clear? It is the property of the existence of additive inverse. For this we have a matrix A and another matrix minus A, such that A minus A equals to 0. So that is minus A is the additive inverse of A or negative of A. Now see what is the negative of a matrix. Negative of a given matrix. the negative of matrix A, if we have a matrix A, then the negative of a matrix A is equals to minus A is equals to minus 1 multiplied by A. If we multiplied minus 1 to the given matrix, then we get a negative of that matrix. Okay. Let we have a matrix A is equals to 1, minus 1, 2 and 3. Last is 3. So, its negative is minus A, that is equals to minus multiplied by 1, minus 1, 2 and 3 is equals to minus 1, plus 1, minus 2 and minus 3. It is the negative of the given matrix A. Okay, let's see the next property. Next is the difference of two given matrices. How to find the difference of two matrices? If A and B are the matrices of the same order, then their difference, that is A minus B is equals to A plus minus 1 into B is equals to the difference of matrices A and B is equals to, in other words, we can say that it is a sum of matrices. It is the sum of matrices A and minus B. Okay. It is either a difference of matrices A and B or sum of matrices A and minus B. For example, let A be a matrix is equals to 4, 6, 2 and minus 4. And B be another matrix that is equals to 2, minus 3, 1 and 2. So, A minus B is equals to A plus minus 1 into B is equals to 4, 6, 2, minus 4 plus minus 1 multiplied 2 minus 3, 1, 2. That is equals to 4, 6, 2 minus 4 plus, when you multiply it by minus 1, that is minus 2 plus 3 minus 1 and minus 2. Okay. Now, adding the corresponding elements, then we have 4 minus 2, that is 2, 6 plus 3 is 9, 2 minus 1 is equals to 1, minus 4 minus 2, that is minus 6. It is the difference of A minus B, difference of matrices A and B. Let's see the next. Next property is multiplication. Multiplication of a matrix by a scalar. Multiplication of a matrix by a scalar. Let's see it. If a matrix A equals to Aij order m into n is multiplied by the scalar k. K is any scalar. Then the product Ka is obtained by multiplying each element of A by K. Let's see again. We have a matrix A is equals to Aij order m into n. If we find the Ka, then we have to multiplying each element of A by K. For example, let we have a matrix A is equals to 2, 3, minus 1, 4 and a scalar K equals to 5. Then Ka, the product of the scalar and the matrix, is equals to 5 multiplied by 2, 3, minus 1, 4. On multiplying each element, then we have 2 into 5, minus 1 into 5, 3 into 5 and 4 into 5. That is equals to 10 minus 5 and second row 15 and 20. It is the product of K and A. Let's see the next operation is multiplication of matrices. अभी हमने क्लियर किया था multiplication of a matrix by a scalar. Now हम क्लियर करेंगे multiplication of given two matrices. Okay? Two given matrices को multiply कैसे करना है ये हम क्लियर करेंगे. Let's see. Two matrices A and B are conformable for multiplication if the number of columns in matrix A is equal to the number of rows in B. Number of columns in A is equal to the number of rows in B. Okay? It is the must required property. So let A is equals to Aij order m into n, then B is equals to Bij of order n into p. Number of column in A is equals to number of rows in B, that is n. Then AB is equals to Cij of order M into P, where C is the element of product AB. Okay. Where Cij is equals to the element of AB. It is the element of the product of the two matrices. For example, let A be a matrix 2, 3, 1, 4. Its order is 2 into 2, 2 rows, 2 columns. And B be in another matrix that is equals to -1, 2, 4, 2, -3, 5. It is of the order 2 into 3. Here, number of columns in A is equals to the number of rows in B equals 2. Okay. Number of columns in A is equals to number of rows in B. So, AB is equals to Cij of order 2 into 3. 2 are the rows in A and 3 are the column in B. So, row into column. So, AB is equals to C11, C12, C13, C21, C22 and last is C23 because it is of the order of 2 into 3. So, total elements 6. Okay. So, first element. First we have to find the first element C11. How to find C11? For this we have to multiply first row of A into first column of B. First row A की first row that is 2, 3 को first column से multiply करना है. First row is 2, 3 and first column of B is -1 and 2. Okay. So 2 multiplied by -1, 2 multiplied by -1 plus 3 multiplied by 2. 3 multiplied by 2 that is equals to -2 plus 6. So first element is 4. Let's see the next C12. C12 is equals to first row and second column of B. First row of A that is 2, 3 and second column of B that is 2, -3. 2, -3. On multiplying we have 2 into 2 plus 3 into -3 that is equals to 4 minus 9 is equals to -5. Next is C13. First row of A that is 2, 3 and third column of B that is 4, 5. On multiplying we have 2 into 4 plus 3 into 5 that is equals to 8 plus 15 is equals to 23. Next, second row. So, C21 is equals to second row of A. It's 21. So, second row of A that is 1, 4, 1, 4 and first column of B that is -1, 2. On multiplying we have 1 into -1 plus 4 into 2 is equals to -1 plus 8 that is equals to 7. Next C22 is equals to second row of A, that is 1, 4, 1, 4, and second column of B, that is 2, minus 3. On multiplying, we have 1 into 2 plus 4 into minus 3 is equals to 2 minus 12 equals minus 10. Okay. Next, last C23, that is equals to second row of A, that is 1, 4, and third column of B, that is 4, 5. So is equals to 1 into 4 plus 4 into 5 equals 4 plus 20 is equals to 24. Okay. So let's see the matrix AB, product of A and B, is equals to, first element is C11. C11. C11 is 4. So first element is 4. C12 is minus 5. C13 is 23. C21 is 7. C22 is minus 10. And C23 is 24. It is AB, product of given two matrices A and B. Its order is 2 into 3. Here 2 rows and 3 columns. Okay. Now let's see the properties of multiplication of matrices. Properties of multiplication of matrices. Okay. Let's see the first property. The associative law. The associative law. According to this law, let A equals Aij of order m into n and B equals Bij of order n into p and C and another matrix is equals Cij of order p into q, then according to this law, AB multiplied by C is equals to A multiplied by BC. AB का मल्टीप्लिकेशन हमें करना है, सो A का जो नंबर ऑफ कॉलम्स है वो B के नंबर ऑफ रोज से इक्वल होना चाहिए. फॉर नेक्स्ट साइड BC का मल्टीप्लाई हो रहा है, सो B का नंबर ऑफ कॉलम इज इक्वल्स टू नंबर ऑफ रोज इन C. ओके, लेट्स सी नेक्स्ट. Next is the distributive law. Distributive law. According to this law, if we have a matrix A equals Aij of order m into n and B equals Bij of order n into p and C equals Cij of order n into p, then according to distributive law, B plus C multiplied by A is equals to AB plus AC. AB plus AC. Okay. If we multiply the sum of B plus C by A, that is equals to the sum of AB and AC. Okay. Let's see the next. Next is if A equals Aij of order m into n and B equals Bij of order m into n and C equals Cij of order n into p, then according to the distributive law, A plus B into C is equals to AC plus BC. If we multiply the sum of A plus B by C, then it is equals to the sum of AC and BC. Okay. Let's see the last property of the multiplication is the existence of multiplicative identity. The existence of multiplicative identity. It is the last property of the multiplication of matrices. Let A be a square matrix. Let we have a square matrix A. Then according to this, there exists an identity matrix. There exists an identity matrix I of the same order. There exists an identity matrix I of the same order such that IA is equals to AI is equals to A. IA is equals to AI is equals to A, where I is the identity matrix of A. Okay, clear?